Welcome back to part 2 of our 4-part series on HVAC design requirements for NYC public schools, based on School Construction Authority standards. In this video, we'll cover unit ventilators, HVAC equipment sizing, boiler inspections, gas leak detection, burner safety, BMS, DDC controls, kitchen ventilation, and compressor room ventilation. In the first part of this series, I went into a lot of detail, maybe too much detail for some viewers, because I wanted to capture as much information as possible. For today's video, I've compressed the content so you'll get only the key points from each section. If you ever need to dive deeper and go through every detail of the SCA standards, I recommend visiting the official SCA Design Standards page at www.nycsca.org. That's the best source for the complete requirements. This video will give you a practical overview that's easier to follow while still covering the most important takeaways. Let's get started. Section 6.2.12, Unit Ventilators. Non-electrification projects. Replace existing horizontal unit ventilators with the same type. Electrification projects. Must use vertical ventilators with energy recovery wheels. Horizontals without energy recovery are not allowed. Large areas like corridors, lobbies, and cafeterias require central ducted ventilation system. Unit ventilator fans and coils should be sized to handle loads using a mix of fresh and recirculated air. Acoustics. Classrooms must stay under 45 dBA, NC 40, verified by an acoustical consultant. Section 6.2.13 Arrangement and sizing of HVAC equipment. Heat pumps, DX or dual temp with approved chillers, required for all spaces. Heating. Size units for 12.8 degrees Fahrenheit outdoor air design condition, not at ARES 47 degrees Fahrenheit rating. Boiler-based systems need special approval. Cooling. Includes sensible and latent loads, must handle spring transition conditions. Load calculations required at design milestones. CIP projects, 50% and 100%, capacity projects, 60% and 100%. HVAC schedules must include transmission, infiltration, ventilation, and safety factors. Designers must ensure layouts can accommodate all approved manufacturers' equipment based on mechanical room sizing, electrical power feeds, noise limits, slab openings, roof access and catwalks, vibration isolation and seismic restraints, and NYC Fire Code compliance. Section 6.2.15, Boiler and Chimney Cleaning and Inspection Requirements. For B100 burner retrofits, replacement projects, boiler, burner, chimney must be inspected and cleaned. No boiler, burner, gas appliance can be tied to a damaged chimney without proper lining. Soot cleaning of boiler fire tubes is required. All new or altered chimneys must pass a smoke test per code. Stainless steel liners. Not always required for biodiesel retrofits, unless inspection shows deterioration. Section 6.2.17, Gas Leak Detection and Alarm System. Required for new or retrofit project, where steam, condensing hot water boilers burning natural gas or dual fuel. Detectors installed 18 inches below ceiling near boilers, heaters, and gas meter rooms. At 25% LFL, detectors trigger alarms, close valves, shut equipment, start exhaust fans, and notify fire alarm and school operating console. Systems must run on emergency generator. Gas meter rooms must have explosion-proof fans, lights, sealed penetrations, and outside air intake. FDNY approval required before installation. So, I8N summary. Gas leak detection systems are mandatory in SCA projects with natural gas, dual fuel boilers. Detectors must be strategically located. Alarms must shut down fuel systems and notify fire alarm, BMS. And systems must meet strict NYC code and FDNY approval. Section 6.2.19, Boiler burner safety considerations for non-condensing boilers. The burner management system must include a full pre-purge cycle for air changes. Draft dampers must prove 100% open before the fan and ignition sequence start. During idle cycles, the damper is required to close to about 70% for safety. Post-purge duration must follow CSD1 rules. In the event of a shutdown or smoke alarm, The damper returns to full open to clear combustion gases. Oil systems. Each boiler must have its own burner pump. Piping needs safety valves, strainers, and recirculation to prevent leaks and clogs. Transfer pumps must be oversized at about 2.25 times total consumption. Burners use anti-drip nozzles and fine strainers, with tanks and piping cleaned before service. Remote shutoff controls outside the boiler room must also stop transfer pumps. If ceiling height is tight, a back pressure regulator can replace the standard return loop. Remote oil shutoff controls outside boiler room required. Gas systems. Gas meter rooms need explosion-proof fans and leak detection. This section enforces strict safety, control, and code compliance for non-condensing boiler burners. It covers purge cycles, damper positions, burner pump requirements, oil piping schematics, shutoff devices, venting, emergency shutoffs, and monitoring systems for both oil and gas equipment. All designs must comply with ASME CSD 1-2011, 2022 NYC Mechanical Code, and NFPA standards. Section 6.2.20 BMS, DDC requirements. Case A. Full backnet BMS, new construction and modernizations. Must connect to central host control station with Niagara graphics, Cisco switches, and FMSI involvement. Case B. Used in capacity projects and larger capital improvements. These are local-only networks, not connected to the central host. They still require Niagara graphics, backnet scheduling, and must meet energy reduction goals, 10% for burner retrofits and 5% for HVAC control upgrades over $2 million. Case C. DDC only, for small projects such as standalone RTUs or gym units. These have no networking or graphics. Scheduling is done through local controllers or time clocks, and commissioning is handled by the project's commissioning authority instead of FMSI. All graphics must be Niagara-based, systems must use backnet, and projects must follow setback settings, 72 degrees Fahrenheit dropping to 55 degrees Fahrenheit in winter, and 78 degrees Fahrenheit maintained in summer. Morning start cycles and purge modes are also required. Section 6.2.22 Kitchen ventilation. Applies to full kitchens, warming pantries, and cafetoriums. 2 design approaches. Case 1. Combined cafeteria, kitchen unit, cheaper, preferred for small jobs. Case 2. Separate cafeteria unit plus dedicated kitchen makeup unit, higher efficiency for large projects. Kitchens must be negatively pressurized, 10% more exhaust than supply. Kitchen air can't return to cafeteria units. Exhaust systems include washroom, toilet, general exhaust fans, and hood exhaust interlocked with gas valves. SCVAV and DCV required. Kitchen. 72 degrees Fahrenheit winter, 82 degrees Fahrenheit summer. Case 1, or 78 degrees Fahrenheit summer, Case 2. Cafeteria. 72 degrees Fahrenheit winter, 78 degrees Fahrenheit summer. All hoods need FDNY performance testing, inspections approval. Exhaust outlets must be at least 10 feet away from intakes. Section 6.2.23 Compressor room ventilation. Compressor rooms must ventilate 1,100 CFM per remote condensing HP. Makeup air cannot be taken from kitchen, must be 24/7 ambient source. Preferred option. Locate condensing units outdoors in secured cages. Storage rooms for food must be kept between 50 degrees Fahrenheit to 70 degrees Fahrenheit using heat pumps. If BMS exists, integrate room temp and humidity sensors. Kitchen storerooms must be kept between 50 and 70 degrees Fahrenheit using an electric heat pump system. The outdoor unit should be placed next to the walk-in condensing units, and if they're outdoors, they must be in a secure cage. If that's not possible, the outdoor heat pump unit must be in another secured location. For projects with a BMS or DDC system, the controls contractor must provide both temperature and humidity sensors, and integrate them directly into the network. That wraps up part 2 of our series on SCA HVAC design requirements. We covered everything from unit ventilators to kitchen ventilation. In part 3, we'll continue with more detailed system standards and design practices. Don't forget to like, subscribe, and share this with anyone interested in HVAC design for NYC schools project.